math geometry class. I'm going to go over the homework for today just to save us some time in class and just to make any clarifications for future homework. So please watch this video even if you got it all. I hope it's not too long, but I'm actually doing your homework. So we'll see what happens in case you couldn't get your homework especially. So let's just start. We're going to do, it's lesson 25. And it's 6 through something or other. So let's just start with 6. Find an equation of a line that passes through the point 3, 1 and is parallel to the line which passes through the points -1, 2 and 3, 4. Alright, so you have 2 points and we're trying to find another line. So if we were to plot these, this may be a little painful of a class to do because I'm going to go into detail a little bit. But I want to make sure that you understand everything. Having a little trouble drawing here for some reason. Okay, so I have no idea why I can't finish this graph. So if we're going to plot these points, we have -1 and then we have 2. So we plot that and then we have 3, and it's not going to draw down here, but it's 3, 4, something down there. So we're going to get a line going down this way. And we want to get a graph. Let me just erase this whole graph since I can't. My board is apparently cut off today. Let's see if I can get that to stick. Nope. Okay. So let's just draw the graph down here. We're going to have a truncated board today. We have our y-axis and our x-axis. So we have the point -1, 2. And we have the point 3 and 4. 3, 4. So we have a point up here, and we're going to connect those with a line like such. Didn't quite hit it, but you're going to get the idea. Okay, we're going to write an equation for another line that goes through the point 3, 1, which is parallel to this line. So we're going to come up with an equation of a line that's parallel to the line that goes through these 2 points. So the first thing you have to do if we're going to get parallel is we need to find the slope of these 2 points. I think I should make these points bigger so at least they look like they're on the line. So we find the slope, so we do the slope formula. Slope is y2 minus y1 over x2 minus x1. This is a formula that should be memorized and stored in your head. So here we go. So we're going to get the second y-coordinate is 4, the first y-coordinate is 2, the second x-coordinate is 3, the x-coordinate is -1. So we're going to get 2 over 4. So we're going to get our slope is 1/2. If we add these, it's going to be 4. All right, so we have the slope is 1/2. Now we're going to write an equation of a line with the same slope, because if 2 lines are parallel, they're going to have the same slope. So we're going to use this point. This is going to be our x and our y, and we're going to use this slope, and we're going to write an equation of a line. So we say y equals mx plus b. You take the point above, so it's going to be 1 equals our slope is 1/2, our x is 3, we have to find the b. So we're going to get 1 equals 3/2 plus b, subtract 3/2. This would be the same as 3 over 3. Whoops, we're doing halves, not thirds. So it's going to be 2 over 2. So if we subtract, we get b equals -1/2. So that's our y-intercept. And so then we just write the equation of a line, y equals mx. So that's going to be our slope. We put the x and y back in, -1/2. And that's the solution to number 6. Okay, number 6 is an old one. We learned it in Algebra 1. So I'm hoping that you got that one, but if not, there you go. Okay, let's go to the next one. Here's where we start getting into trouble. Number 7, we went over these a lot in class, but it still seems like it's something that takes a while to sink in. This is an exponential function because we have a variable as an exponent. All right, so it's either going to look like this. It's going to grow really quick. Did you ever hear of anything growing exponentially? It means it grows quickly or decreases quickly. Okay, so it's going to look like one of those 2 functions. If the base, now that's your base, if your base is greater than 1, it's going to look like this guy. If your base is less than 1, it's going to look like this guy. This one is greater than, this is greater than 1, so it's going to look like this graph. But in order just to get an idea of that, we make a little XY chart. F of x is always the same as y. So when we do our chart, we're going to pick some values for x, and we're going to put it in. We always pick 0, and we're going to get 1. 4 to the 0 power is 1. Then we pick 1. 4 to the 1 power is 4. And we pick negative 1. 4 to the negative 1 power is not negative 4, it's 1 over 4. Remember the negative exponent, if we have x to the negative 1, remember that's 1 over x, so it flips. So we're going to get 1/4. And if we're going to graph this guy, we'll graph it here. We get 0, 1. All exponential functions without something added or subtracted to it, it's going to go through 1. Then we're going to get 1, 4, 2, 3, 4, 1, 4, and negative 1, 1/4. And you can see how it looks like this one right here. It's never, ever, ever, we talked about this in class, going to hit the x-axis. It's never going to be 0. There's no possible values that you can put in for x that's going to give you 0. So it's never going to touch the x-axis. And it's going to grow very quickly, get really, as x increases, y is going to grow even faster. That's why it's an exponential function. So let's move on to, we can do the next one, number 7. Number 8 is very similar. 8 looks like this. G of x. Functions are always labeled f, g, and h. Occasionally something else, but the most popular ones are f, g, and h. All right, so what we talked about is if the base is less than 1, it's going to look like this. All right, so we do exactly the same thing. X, y, 0, 1, negative 1. We put a 0 in, we always get 1. 1/4 to the 0 power is 1. If we put a 1 in, 1/4 to the 1 power just gives you 1/4. And 1/4, all we're doing is we're replacing this x by the x values right here. To the negative 1, this is where it flips. We're going to get 4. So if we go to graph this guy, all right, we go to graph him. So we get 0 is 1. If we put a 1 in, we get a 1/4. And if we put a negative 1, we get a 4. So we're just getting a basic shape of these graphs. They're not totally accurate. And we're never, ever, ever going to hit 0. It's always going to be approaching it. It's going to be getting smaller. The bigger the values for x, the smaller the values of y are going to be. All right, so that's 6, 7, 8. Let's move on. I don't know how to fix my whiteboard today. It's just having multiple troubles. Hold on a second. All right. Let's see if I can grow it here. I can't even get to my new whiteboard. All right. Something's totally wrong. All right, let's see if I open a new window, what happens. Hold on, guys. Technical difficulties. All right, let's see. All right, let's see if a new board helps us at all. All right, I need a color here. All right, so now we're on to 9, these absolute value problems. You have to learn these. There's nothing else I can say. This one has 2 parts. It says x is an element of the real numbers and such that x plus 3 is greater than 6. Okay, don't let all that scare you. There's only one variable here, x, so it's just going to be on the x-axis. All right? It's just going to be on the x-axis. There's not going to be a y-axis. So we take this part and we plop it out. So we get the absolute value of x plus 3 is greater than 6. Talked about in class, if it's greater than, your graph's going to look like this. Okay? It's going to go opposite directions. If it's less than, they're going to go in between the 2 dots. Okay? That's how it's going to be. All right, so this is greater than. You're going to get two answers. When you have absolute value, you always get two solutions. So how do you get the two solutions? Well, you have the solution when you take what's inside of there, the positive value, and set it greater than 6. Where that 5 came from. Then you take the opposite. So instead of positive x, we're going to have negative x. Instead of having positive 3, we're going to have negative 3 is greater than 6. So there's always going to be two solutions to these. What's inside of there, and then the opposite. This is the opposite of what's inside of there. You solve these little guys, and it's easy. Subtract 3. You shouldn't even need to write this anymore. So you get that one. And then this one's a little bit more complicated. You add 3 and you get 9. When you divide by a negative 1 with the inequality, you have to flip your sign. So you'd say x is less than negative 8. So when you go to do your graph, you don't need a lot of detail on your graph. We do need the 3. So x is going to be greater, not and equal to 3. And it's going to be less than negative 8. Like that. All right? And that's going to be how you do part A. That's it. All right, let's do part B. If I can do part B here. My graph is having a lot of trouble. My paper's having a lot of trouble. Okay, B. This one I'm just going to take it right out. It's x minus 2 is less than or equal to 5. Okay, two cases. This is a less than, so I can tell you right now it's going to be in between the 2 points. We're still going to get two solutions. This is our and. It's going to be where it intersects. So we get x minus 2 is less than or equal to 5, and we're going to get the opposite. So we're just totally opposizing it. You can write that down, Sam. Okay, so what's inside of here is less than or equal to 5, and then the opposite. So instead of positive x, it's negative x. Instead of negative 2, it's positive 2. Solve these guys. It's less than or equal to 7. Negative x is less than or equal to 3. Divide by negative 1, so we flip our sign. We don't want to forget to flip our sign. All right, important thing. Greater than or equal to negative 3. So your graph, just like what I said, you're going to have your negative 3. This is colored in because it's and equal to. 7 is out here, colored in. And you're going to fill in between because it's going to be greater than negative 3, but it has to also be less than 7. So it's going to be in between. All right, we are just moving on really fast here. So let's do the next one. I think my board fixed itself. Okay, 10, you have to determine whether it's a function. Well, these are the easy ones. We should all get these. I'm just going to sketch them really fast. This is indeed a function because when I do the vertical line test at any place, it only hits 1 point. So A is yes. B is the same thing on its side, like that. When we do the vertical line test, it hits 2 points, so it's a big fat no. All right, the next one is C. This one goes like that. Vertical line test absolutely works, so this is a yes. And D is, let's see if I can just squeeze that on, is a squiggle squirm. And that one, when you do the vertical line test, it is also a yes. So 10 is, they want to know if it's 1-to-1. This one is, A is not 1-to-1 because every value of x does not have a value of y. It does have a value of y. Why is it not a 1-to-1? This is 1-to-1. This is 1-to-1. This is not 1-to-1. I'm not sure. I'll have to get back to you on that. Okay, let's go to 11. All right, nightmare problems. F of x equals the square root of 2x minus 1. You have to determine the domain. What a domain is are the x values that make it work. Now, there's x values that are illegal. X values are illegal there's two cases. One, absolute value, square roots, the value under square root, under a square root must be positive. And 2, you can't have 0 in the denominator. So we have to figure out which values of x will not cause these two cases to happen, or cause this one to happen. So as soon as you see a problem like this with the square root, you take it and you say, this has to be greater than or equal to 0. So it has to be positive. Positive means greater than or equal to 0. So you solve this little guy, 1, and you get x equals 1/2. Or it has to be greater than or equal to 1/2. I'm going rather fast, so it has to be greater than or equal to 1/2. Whoops, we're not doing that. So we have to write our little thing. It's just always the same. X is an element of reals. You just always put that, such that x has to be greater than or equal to 1/2. And that's it. It can be anything else, but it can only be values that are bigger than 1/2. If I were to put in a 0 here, if x were 0, I would get -1 under the radical, and that's illegal. These are the values that are legal. And domain are your x values. Domain are your x values. So if you had like an XY chart, something like this, these would be all the values that you're allowed to put in for x. This one's called your domain, and this one's called your range. The range or your y value is what comes out. You are not allowed to put anything less than 1/2 in here for your domain. All right, let's try B. This one is 1/, this is a double whammy, square root of x minus 3. Now there's two cases. This has to be greater than or equal to greater than 0. It cannot be equal to 0. It cannot be 3 because that would be equal to 0. So we don't put the equal to 0 thing. You cannot have 0 in your denominator. So in this case, we don't put the and equal to under it because we can't have 0 there. So you just solve it. You'd say x is greater than 3. And that's what you would write here. X is an element of the reals such that x has to be greater than 3. It can't be equal to 3. All right, it cannot be equal to 3 because 3 would give you 0 in the denominator. All right, last one of these types. C, h of x is equal to 3/x minus 1 times x plus 6. Okay, no square root, so we don't need to do this kind of thing, okay? No need for that because that's only for square roots. The problem here is we have to say what's going to make this equal to 0. Well, there's two things. X cannot equal 1 and x cannot equal -6 because they're going to be values that when you put them in, you're going to get 0. So when you write your set notation, you'd say x is an element of the reals such that x cannot equal 1 and x cannot equal -6. So you're basically just setting the denominator equal to 0, and you can see it's going to be 1 and -6. Okay, next. We are on 12. Now for 12, 13, 14, and 15, these are the last ones you have to do. I guess you have to do 16 as well. No, maybe not, up to 15. You need to know these triangles. We're going to have a quiz in class on some geometry, and I'm also going to have you write these triangles down because I don't think you have them yet. This is a 30, 60, 90 triangle. It's going to look just like my 45, 45, 90 triangle, unfortunately. This is our 45, 45, 90. You don't write 90, you just put the little box. Okay, the sides of all 30, 60, 90 triangles have the same ratio, which is 1, square root of 3, and 2. 1 is smaller than the square root of 3, so it goes opposite the smaller angle. 90 is bigger than 60, so 2 is actually bigger than the square root of 3. So if we were to put the square root of 3 in our calculator, which I have right here, let's see what it is. it's 1.73. So you can see it goes 1, 1.73, 2. All right. Let's go to the 45, 45, 90. It's 1, 1, square root of 2. You can write that on your paper right away. I'm going to tell you some things you have to memorize that would make your life a lot easier. One of them, here's just a couple. The sine of 30 is always going to be 1/2. Let's look at it. Sine. So we have our SOHCAHTOA. Okay, sine goes with opposite. So the opposite of 30 is 1 over the hypotenuse is 2. So the sine of 30 is 1/2. You can memorize that. In the same way, the cosine of 60 is also 1/2. Let's look at that. So it's going to be adjacent over hypotenuse is 1/2. And then I would just say there's more you can memorize, but let's just stick with these. Get these down first because it really helps if you just know those. All right, so let's go to 12. 12 says sine of 60 degrees, of course there's an A and a B, sine of 60 degrees minus cosine of 30 degrees. Of course they're not up here, are they? They're not up there, so we have to figure these out. So what you do is you pick your, you know you're going to need your 30, 60, 90 triangle. You do the sine of 60. Sine is opposite over hypotenuse. So it's going to be square root of 3 over 2. You can memorize that if you want. Square root of 3 over 2. Cosine of 30. So cosine is adjacent. Here's adjacent to hypotenuse. So it's going to be square root of 3 over 2. Same thing. Not funny. Square root of 3 over 2. So this one's just going to end up equaling 0. All right, let's try B. B is, lost my place here, square root of 2. This one gets a little bit more complicated. Over 2 cosine of 45 minus 2 sine of 60. So this one you have to find these two things and then you multiply them by what's in front of them. So let's just carry it along. Square root of 2 over 2 cosine of 45. So this time we want this triangle. Cosine of 45 is the same as sine of 45, which is fairly convenient. So it's adjacent, so it's 1 over the square root of 2. So it's times 1 over the square root of 2. Let's just leave it all messy like that. 2 sine of 60. Well, we just did the sine of 60 right here, but let's do it again. Sine of 60 is opposite over hypotenuse. So it's square root of 3 over 2. Let's make sure I copied that right. That doesn't seem quite right, but it is. Square root of 3 over 2. All right, this is number 12. I just want to check everything with the answer books, make sure everything's going well. All right, so the 2's are going to cross out here, and these are going to cross out. So you get 1/2 minus the square root of 3, and you can just leave it like that. All right, that's that. Let's move on. 13. Okay, so this is another odd bird. F of x equals 2x, and g of x equals 1 minus x squared. These are simply substitution problems. So part A, you have f g of 2. So that means you're going to take the f function, evaluate it with 2 in it, times the g function. I like to rewrite these. F of 2 times g of 2. So all this means is you're going to go to the f function and you're going to replace the x with the 2. So we're going to say 2 times 2. Now we go to the g function and we replace the x with the 2. So it's going to be, this one takes a little bit more effort. Let's just put it up here. G of 2, we're going to replace the x with the 2. So it's going to be 1 minus 4 is negative 3. So this one's going to be negative 3. G of 2 is negative 3. So you just multiply all those guys together and we're going to get negative 12. All right, that's the first one. That was the easy one. Okay, let's go to B. B is f divided by g of 2. So it's the same thing. You take f of 2 and you divide it by g of 2. We found out f of 2 right here is 4. So we're just going to take 4. G of 2, we already did it up here, is -3, and that's your answer. It's going to be -4/3. Now for the tricky part, without getting rid of the functions here. Okay, so C is a composition of functions. C is g of f of x. First step, you need to rewrite this as g of, you say it the same way, of f of x. So what that's saying is do the inward things first. We usually work inward out, so we find f of x. Well, if we go up here, remember we replaced this with a 2, so we're going to get 4. So f of x is equal to 4. So we say g of 4. So you figure out what, this is, I should have put the 2 here. This should have been a 2 all along. 2. So you're going to go to the f function, you go up here, and you put the 2 in, and you get 2 times 2 is 4, and that's what that is. Now we go to the g function, and we replace the x, this time with a 4. So we're going to say g of 4 is equal to 1 minus 4 squared, which is going to be -15. Those are odd, but they're not hard. You just you figure out the inward one, and then you go and put that answer in the other one. All right, moving on. I hope this is helping. All right, 14. These start looking very scary. F of theta. So now they're combining these functions with the trigonometry. Yikes. Cosine of theta and minus, yikes, 1/2 sine of theta. All right, did I copy that right? Okay, and they say that find f of 30 degrees. So what that means is you go to the f function and you replace the theta, because that's what's in the parentheses, with 30. So then it turns into like the previous problem, a couple of problems back. So it's going to be the cosine of 30 minus 1/2 sine of 30. So we need our 30, 60, 90 triangle to come out. Play with this here. So we get our 30, our 60, our 90, our 1. I always do 1, 2, square root of 3. Okay, make sure it's across the numbers are across from the right angle. 1 goes with 30, square root of 3 goes with 60, 2 goes with 90. All right, so you carry this along, square root of 3 over 2, cosine of 30. So it's adjacent over hypotenuse. So it's square root of 3 over 2. Okay, that was easy. Minus 1/2, and I told you to memorize the sine of 30 is a half. Well, let's just do it anyway. Opposite over hypotenuse. So we get opposite would be 1 over 2, it's 1/2. So we get times 1/2. Square root of 3 times square root of 3 is 3 over 4 minus 1/4, which is 2/4, which is 1/2. So number 14, the answer is 1/2. Almost done. 15. Okay, this even gets more bizarre. M of theta equals sine of theta. N of theta equals tangent of theta. Okay, I probably already lost you. Okay, we're supposed to find 2, square root of 2, m of 30 degrees minus 2, n of 30 degrees. So all that's saying is we're going to take the square root of 2 and we're going to put 30 in right up there. We're going to go to the m function and we're going to replace the theta with 30 degrees. So it's going to be sine of 30 degrees minus 2 times, we're going to go to the n function, we're going to place the theta with 30 degrees. tangent of 30 degrees. So we do need our little thing here, 30. Once you write it on your paper someplace, that's good, but it's helpful sometimes just to keep rewriting it. Okay, square root of 2, sine of 30, opposite over hypotenuse, or if you have it memorized, 1/2. So it's 1/2. And then we have to do the tangent of 30, which is opposite over adjacent. So it's 1 over the square root of 3. 1 over the square root of 3. Okay, you have to simplify this. So it's going to be square root of 2 over 2 minus 2 over the square root of 3. You can't leave square root of 3 in the denominator. It's illegal. You need to rationalize. So your final answer is going to be square root of 2 over 2 minus 2 square root of 3 over 3. And you can just leave it like that. All right, 16. I'm not sure if you had 16. I guess I should look at that real quick here. All right. I have it here. Nope, it only goes up to 15. So, all right, that's it for this homework. I don't know if I'll have time to do the rest of them, but this will get rid of some of the time in class to do the other homework problems. So that's it. Let me try to shut this thing down.